Alright, got these Virpil controllers here, and I wanted to make a quick video over some of the modifications I made in the programming that I thought was interesting. These are the alphas, not the primes, but just the alphas. And what I've done, other than normal setup and using a Z extension here, is I set this one up with the Cosmos cams. So, very light, smallest tension, to where you can make very nice and fine movements. On this one I set it up with the Cosmos cam forward and backward, and then I use the clutches that are inside of here to create drag in the forward and backward position for a throttle. So this would actually work kind of like a throttle where it stays in position. I left the spring in there, but it doesn't really take that much clutch to get it to hold into place. The problem with that being, in a game like Star Citizen where you have reverse and forward, you need to know where 50% is. You can see there as I get to 50%, it lights up white. I'm going to show you how I did that in the programming. And then also, these have little trigger switches that go forward and backward, right? And what I've done is I've used that as a state. This is a normal state. This is a secondary state. State 2 in this case. What that means is this controller has 31 buttons. You can use all of the buttons individually and assign them to key bindings in a game. And then when you switch over to another state, it shows red, being that you're in another state. All of those buttons now can be reassigned to a different number. It's not like pushing the shift or control and the number. It's a whole new number. So for example, if this was button number 5 and I pressed it, and then I go to a different state and press it, it now becomes button number 23 or whatever, for example. That only works for this controller. So this controller changes when I go into this state, but all of the buttons on this controller would stay the same. You see there's no light change in this, indicating it's in the same state. That same button is the same button no matter what the other controller's doing. Now that being said, I created a state in this one. You can see it turns green. And when that state changes, this controller also changes. So now they're both in a different state. All of their buttons do something different. I use that in Star Citizen for like mining mode and salvaging, whereas I use the red state on the right controller for missile mode. And I've remapped all of the buttons on this controller while this is in missile mode, and I've remapped all of the buttons together on both controllers when it's in that mining mode. And I'll show you how I did that in software. Alright, when you very first get the program, you're going to want to go to Virpil's website and download 3 different programs. They usually come together. That's going to be these right here. This one is the main program. This is how you're going to manipulate the software within the device itself. This is going to be what Windows sees when this device sends a command to Windows. This is going to be a better tester than you'll get out of Windows, but they also have a module you could use if you need. And then this is going to be the program that lets one Virpil device communicate with another Virpil device, which is how we made both of those joysticks turn green at the same time, and I'll show you that at the end. So first let's go into this program. Alright, this program does take a minute to load up, and you're going to hear Windows activating in the background. And you can see here that I've already got both of my joysticks registered in the program. What I have heard is helpful is if you just plug in one device at a time and then program it, or update the firmware and then program it, and then unplug that, replug in a different device and do that. I did that in the beginning just so I could tell the difference between the two, but you can see they're actually listed. This is a left and this is a right. And I'm not daisy chaining them together. They're going individually into a powered USB port separate, so it doesn't draw my computer's power, and they're not going between each other at the same time. They're probably going to be a little bit of lag because of that, but it's not noticeable that I can tell. So here you can see on my left joystick, the very first thing you want to do whenever you get these is go into firmware, this bottom button, and start an auto firmware update. That's a 7-step process that goes through, updates the firmware, it disconnects the joysticks from Windows itself, and then adds the firmware, and then reconnects it, and then reinitializes. Pretty quick and painless, and they did a pretty good job with the coding. From there, you're going to go to Profile. Now, right here on the profile, it doesn't know which is left or right, but you want to make sure you have the right one plugged in. This is when it's beneficial to plug in one device at a time instead of using them both, because you're going to know which one is plugged in just because it's the only one there. And then you set it to left, and then you set it to right. And I would say after that, it doesn't matter that you keep them plugged in individually for programming purposes, but that's how you get that L and that R designator. Now it comes normally with this button selected, which means no twist. You want to unselect that button to make sure you get your twist access, unless you want to keep it locked down. Then you hit here, create profile. You can have more than one profile in the system, but you have to at least have the one. Now, when you save that profile, it goes actually and saves on the device itself, not in your computer. So you might have several profiles loaded up in this software, but the one that's loaded into the device is the one that'll go with you when you take your joystick to a different computer and plug it in. And if you got the wrong one, you'll have to bring it back, replug it in, and change the profile or update it in that new system. But it's nice that it's modular so that it installs into the device and stays there. And when you make changes, it stays there. But you have to remember this green button up here that says Save VPC Device. Until you click that button, everything that you change here in the software doesn't get changed down into the program. So you gotta remember to keep clicking that button. Now, after you've got your profile loaded, you're going to go over here to axis, and here in axis you can see that there is a value for each axis. As you move this one forward, for example, it gets all the way to 0%. Move it to the back, it gets to 100%. You have to calibrate. Click this calibrate button. If you don't, those values aren't going to be correct. I think mine said 89 to like 4%. So it has to know the entire throw of each axis in that calibration, and it's pretty painless as well. Just make sure not to forget the little thumbstick, the analog thumbstick. It has its own axis. The brake lever has its own axis. Of course, I'm referring again to the Virpils here that I have, the Alpha. Once you got those set up, you remember I told you in the center, because mine, as you go forward and backward, there is no center detent, but it would be nice to know what 0 is. I set up a button, it's a virtual button, when it reaches 50%. I did that by figuring out which one it was. You can see here it's going to 100 to 0. This P2 y-axis is what I'm looking at. And right here, as I move the throttle, you can see it moving. Remember, when you're looking through here, logical means that it's not the physical button, it's the virtual button that's being sent to Windows. The access source is actually the physical controller being moved. You can see that there's a little bit of a lag. It's really not noticeable in practice. But you can also see these little red squares. That's showing you a dead zone. And you can change the dead zone changing here. And you can see as I move within the dead zone, it doesn't change the output that's sent to Windows. This is a pretty good dead zone. I might lower the dead zone on my other sticks. Something to play around with, but something to know. And you do that over here. Now, what I did to set that button at 50% right here, I created a button that was then sent over to this button section, this little blue button section over here on the left. I also created a button at 0 and a button at 100%. If you go back to my twist, it's this bottom one here, looks like. Yep, you can see it has a lot bigger dead zone, even though it really shouldn't, not necessary. I'm using that actually as a booster and as a brake. As I twist back, it becomes a brake. As I push forward, it becomes a booster. And at the very extreme edges, it becomes, it turns off the speed limiter. And as I pull back, it turns off the G-force limiter in Star Citizen or any other game that you want. You can set up detents as you want based on the percentage of throw that's used in that axis. You can see here 0 to 20 becomes a button, 81 to 100% becomes a button, and at full press, either way, is another individual button. All of these axes have this type of manipulation, and you can change the dead zones and even see physically on the screen a change of those dead zones if you manipulate them here. So that's pretty neat. All right, once we're done with that, you want to go over here to the button section. Now, one of the very first things in the beginning when you plug it in, you want to do is make sure that all the buttons actually work. So you want to start pressing them. You can see here I'm pressing the trigger, number 3. Number 3 is lighting up, all the way pressing the trigger, number 4. You can see these over here clicking as well. Red in this program means depressed, okay, active. Blue means that it's been seen. You clicked it, it saw it being clicked, and it recorded that it was clicked. You can reset them to say, let's try that again, and then push them again, and it shows you what's being pressed. So in the very beginning, you want to go through and click all the buttons you possibly can. Hit all the hats. Make sure you press down on the hats. Remember, they're 5-way, not 4-way. These are the decoders on the scroll wheel. It has a 2-step button. That right there is the brake. So when you pull the brake axis, it already has a button built in. You could even build in again in that other section, the axis section, another button all the way at the end. It would be added in down here. Button number 32, I can't figure out where it is. Supposedly this controller has 32 buttons, but I can't find it. It's supposed to do something with the brake axis, but I don't know where it is. Let's see, I missed some here. There they are. It's that bottom thumb switch brake. And 30 is the pinky switch. There you go. So now all the buttons work. Now that I know all the buttons work, you can clear that and start going to work. Now, normally when you set these, I'll click on button number 4, for example. You see a logical button. Remember, I told you that means the button that Windows is being told to press. So it's a virtual button, right? You see physical button, that's the actual physical button on the controller. You see right here, button number 3 is our trigger. That's the physical button. And if we go to physical button 3, we see that when I press button number 3, it's going to tell Windows the virtual button number 3 needs to be pressed. This is a normal mode. This mode applies to what Windows sees, not what is physically happening. So if you invert it, on is going to be off, off is going to be on. If you hit switch, it's going to go on and off for each toggle, like a toggle switch up and then down. You can make down up by inverting it. Or you can make it a switch, so when you switch it up, instead of being on, it would say on off, and you switch it back down, it'd say on off again. Or you can make that button normal, say up is on, down is off, down is on, up is off. All of these are your options. You know, go to town and figure out whichever one you want to use. The shift, now that's the one that's important that we focus on. That is the state that the controller is in. The default state is 0, and you can see here I clicked on this, and you had to go through and select this controller, and then what color I wanted it to be in. This black color just means it's turned off. So the default state is no color on the controller and 0. So in the state of 0, all of the buttons have a press. Remember, I told you we switched it up and they turned green. That was state number 1. In state number 1, the buttons all have a different press. In state number 2, 3, 4, and so on, they all have a different press. I'll show you that in practice by using this program over here. You see, this is the tester that lets you see what Windows is seeing as you manipulate the program. Now, you can see on here, it shows 90 buttons. When you first load this up, it's only going to show the 32 buttons. And then as you add buttons down here, it's going to add buttons onto here. Nothing changes over here, even when you've changed here, until you hit this save button. It goes to the device, because the device is what's sending the signal to Windows. So remember I told you we just clicked all the buttons and we got down to 32. Well, here's 32. What I did is I went through here and I changed all these shifts to 0. If you leave it to off, off means no matter what state the controller is in, that button will do what you're telling it. That 26 button physical will tell Windows 26 virtual. and doesn't matter what state it's in. If you leave it in state 0, then physical button number 26 is only virtual button number 26 when you were in that state of 0. So what I did is I mapped all of the keys to that physical state of 0 except a few. The first one I did changes to is going to be button number 1, because that's going to be my modifying button. What you can do is you can set that button to do nothing other than change the state of the controller, but I wanted it to also send a button switch because I want it to go into mining mode, for example. I want it not only to change the state of the controller, but I also want a button push sent to the game to say go into mining mode. So it's like it's doing two things. I did that by changing the mode to switch. Now you can see here button number 1, when I pull it back into position, it goes into state number 1. When I push it forward, it goes into state number 0. Now over here in the Windows, I have to find my controller, which is this top one here. You can see as I pull back on the trigger, I get a button press on and off. Now I only pulled the trigger back. I didn't pull it back and push it forward. I only pulled it back. Push it forward, it does both. That's what switch means. It goes on off with each pull, which means I pull it back, it tells the game to go into that mode. I push it forward, it tells the game to go out of that mode. This red button is saying that it's pressed, right? And when I pull it back, it says it's no longer pressed, but that doesn't really mean anything because Windows is only seeing the switch. It's not seeing the physicalized button. What that actually does for us, though, by holding the button, is it lets you switch to the other state and stay in that state. Normally, if you change this button to, say, 30, which is your pinky switch, the only time you'll go into that state is by pushing and holding the pinky switch, which means you got to hold it while you're pushing the other buttons and then let go to go back to the other state. Because this is a button that actually physically switches forward and back for you, it takes away that need to hold down another button. You could put it on something like the left trigger. It's pretty easy to push and hold it while you manipulate other buttons, which is still better than in the game trying to tell it to say shift or control button push, because then you have to get a third-party program like JoyToKey to emulate a control or a shift press on the controller. Whereas what this is doing is it's actually sending the new button command instead of a modified button command, if that makes sense. So I mapped all of these to 0 except a couple. You'll see here 2, I turned that off because you can't pull back on button number 2 without the switch being thrown, so it doesn't matter. Button number 5 is the one on the analog stick, so it's the press in, and I want that press in to do the same thing no matter what state it's in, so I put it to off, which is important because you remember we changed those axis buttons earlier to have a detent in the middle. That was a button. Full press is a button. You want to set those kind of buttons also to off so that when those buttons are activated in the operation of the controller, it's not dependent on what state you're in for them to activate or not to activate. That's what that off does for you. It says, I don't care what state you're in, this is the button I'm pressing. When you press physical button number 5, I'm going to send a virtual button number 5 to the controller, or I mean to Windows. So I went through and I set all those to state 0, and then this button 32, I told you I can't figure out what it is, so I just set it to off. It doesn't do anything. And then I started here and I remapped all the buttons starting at 3, 4, 5. I even went through 5 unnecessarily, but I went through 5 and probably shouldn't have. That's probably going to create a conflict. But I remapped all of the buttons again to that state. So when I flick it forward, the light turns to green. Now all of the buttons say this. Button number 7, for example, when I press it, will then say logical button 37 sent to the Windows. I did that for every single button, so that whole controller now is mapped out. And then down here at the bottom, you can see my detents that were set in the axis. I'll demonstrate those. You can see as I press all the way forward on the left thumbstick, you can see there it touches just when it gets to 100%, when it gets to 0. On the twist, It's based on the percentage, and then the button at the very end of the throw. Percentage, button at the end of the throw. And then when I go back to find center, it turns white for me to let me know it's in center. Now I did that by coming over here to this button on the left. It says LED. I set the button that I wanted it to manipulate on what I wanted to do, which is turn on the light that I set here by selecting my controller and then selecting whatever color you want it to be. You can be creative as you want. Now, on top of that, when I went to the right controller, gotta let it load up, go over to the buttons. On top of that, I have a state 1 set, which is exactly as state of the left controller. All the things are the same. Everything is the same here. And when I got past that, I set up a new zone, and I set up that button number 1 in the off position to turn red for me, and then it creates its own whole set of new states for that button. Now, one thing you have to be careful of, because I've taken state number 1 and I've combined it with the other controller, if you tell it to go into state number 1 on the left controller and they both turn green, and then on the right controller you tell it also to go into state number 2, it's going to start double pressing buttons. It's going to press what state 1 thinks it is and what state 2 thinks it is. So you got to turn off state 1 in order for state 2 to work on the right controller, if that makes sense. You'll notice because you're going to get extra button presses. But there's no other way to switch it. Now what you can do, you can see how this says off or it says on. There's a toggle in here. Toggle is irritating to me because I wish it did where you press a button instead of having to hold the button down to create the state. But what it really does is it toggles into a state. And you can set these to be 3 or 4 different states, and as you press that button it just toggles to the next. So far as I can tell, there's no way to turn off the toggle though. So it'll toggle into state 1, and then if you have this set as toggle, it'll go to state 3, 2, and 3, and 4, which is good like on a switch, you know, that has 5 switches. But you can't ever get back to 0. You can't turn off the toggle. There's no option here. So it means if you have anything set to 0, you can't use it anymore. As soon as you start toggling, it only stays in this toggle. And the problem with it is, if you say make this toggle a button, you're going to have to press that button over and over to find through there. So you have to set these all up to different colors. Click, like for example, the pinky button. Click 30 and it'll go to here, and then toggle to here, toggle to here, toggle to here. Well, if that happens in battle you can only press the trigger in this state, and then you toggle. You're going to have to toggle all the way back through to get to the point where you can put your trigger again. So you just need to keep that in mind. It's something interesting you might try later. I know the throttle, I don't have the throttle, but the throttle has a mode positioner switch where you can very clearly look over and see what mode you're in, and instead of having to press a button over and over to toggle, you just switch over to the mode you want. That might be nice. So it'd be something to think of if you have an actual switch that'll switch to different modes. That would probably be the cleanest way to do this. The trigger switches are nice because they can be done on the fly in real time and even in a combat situation. Alright, I think I covered everything that I wanted to about states and how to set up these buttons. Just remember, try not to make any conflicts and map as many buttons as you can, and then push the save button so that it saves over and goes. Now, to wrap it up, I'll show you how to combine them. I'm not very familiar with this little shift tool, but I can tell you how I made it work. I set the source as my left, right here you can see, stick, and then I set the destination as my right, you can see here, stick, and then I just tell it to start. And then now when I switch into that mode, switches both of the controllers. When I switch out, it goes out of that mode. It's not a two-way communication though, so if I make a switch to this one, for example, and go into state 2, this one doesn't know I'm doing anything. It's a one-way device. It seems more like this is set up for something like I was talking about before, where the throttle has, you know, a hat switch that switches over to all the different zones, and then it communicates to all your other devices. I unfortunately at this point only have 2 devices, but I imagine if I add on to the collection I would do something like that. Anyways, I hope you liked it. Enjoy.